Greetings everyone! We are going to go through two topics that I personally find very interesting today. First, we will discuss the request lifecycle in Symfony and go through some code samples on how you can use the Terminate event to change the order of operations executed to improve overall user experience. Afterwards, we'll talk about the elusive data value holders. What are they and how can we use them? Before I start the first topic, a little bit about me. I'm obviously not Nicolas Grekas nor Andreas Braun. A big shout out to the Symfony Berlin meetup group organizers for inviting them last year. You guys set the bar pretty high for the rest of us. 11 years ago, I wanted to learn something more than running loops with Turbo C++. That is all that we did in my programming class one-on-one. I found a lynda.com tutorial on how to write your first web application. Spoiler alert, I did not write any web application, but I did learn all I needed to get into PHP and just loving how there were no pointers. Fast forward to 2013, I have had some experience with Joomla and WordPress, and I was just hired to start a new project with a new team of developers, but there was a catch. It had to be in Symfony. Naturally, the first thing I did was to find a Udemy course so I could get started with the new LTS version of Symfony at the time, Symfony 2.3. And I got lost immediately. I got lost at the routing and I hated everything about it. A little bit more fast forward, and today I work as a consultant and community lead for Symfony and PHP developers at Endava. Our Berlin clients include names most people would recognize internationally, and all of this was possible because of the great community behind this framework. A few words about Endava. This is a large company. It has over 6,000 employees. It's spread around the world, and programmers are located in Europe and Southern America. Endava has helped some of the world's leading payments, financial services, telecommunications, media, technology, consumer products, retail, mobility, and healthcare companies accelerate their ability to take advantage of new business models and market opportunities. By leveraging next-generation technologies, our agile, multidisciplinary teams provide a combination of product and technology strategies, intelligent experiences, and world-class engineering to help our clients become more engaging, responsive, and efficient. Along with investing in long-term customer relationships, Endava recognizes the importance of providing rewarding and challenging careers for our people, and by doing so, has established itself as the employer of choice in certain regions. It goes without saying that we are always hiring, and if any of you would like to apply, just do it. A simple Google search will show you everything you need, and just hit us up. Now, let's continue with the actual presentation, and let's dive right into the juicy part, the request lifecycle. We are going to go through what is shown in the Symfony docs, nothing too much in detail. We're just going to mention the main events because we need to understand them in order for us to talk and dive deeper into the Terminate event. Usually, what happens is that you have a request coming into your web server, web application, website, however you want to call it. And for each request, there is always a response, which will be streamed back to the client. Now, every time that a request is incoming for our application/kernel, the kernel is immediately going to throw the kernel.request event. It's not uncommon that at this event, we might have an event listener who's going to immediately look into the request and the conditions depending on our application and decide whether or not there is a response to be returned immediately. If that's the case and the response object is returned, the response event is thrown and extra things that we need to add to the response are being added. A response then is streamed back to the client, and the terminate event is going to appear, executed, being thrown, and then our full process is going to end. Now, something else that will happen is that we do not have an event listener, or the event listener is not returning a response object. In this case, Symfony is going to resolve our controller, immediately throw the controller event, and afterwards go and resolve the controller's arguments. And then the controller is going to get called. Now, two things might happen again at this point. One is that the controller, after it's executed, will return a response object. When a response object is returned, the response event is being thrown, things are happening, the response is going to be streamed back to the client, and in the end, the terminate event is going to be thrown again. Now, going back again to the call controller, something else that will happen, and it's not uncommon, is that we do not return a response object. What we do return instead is that we usually return HTML markup or plain strings. In this case, the view event is going to be thrown, and the view event's job is to take this non-response content and transform it into a response object so that the response event can be thrown once again. The response now will be streamed back to the client, and surprise, surprise, the terminate event is being thrown once more. It should be clear that the kernel terminate event is pretty consistent no matter what the path that the kernel response relationship looks like. From the docs, I have a quote here that says, "Typical purposes: to perform some heavy, quote-unquote, action after the response has been streamed to the user." And that's it. That's all you get for the kernel terminate event. There are some examples, of course, but nothing more. Now, I would like to take a step back a little bit and ask everybody, have you ever written code like this? In the code shown here, there's a small snippet of a pseudo action, let's call it like this. It's called the register action. There is something happening and something is being returned back from the twig render method. Let's take some time and look at what is happening exactly. So, a form object is being created from the form factory. If the form is not valid, we immediately return the templates/new registration.html.twig and we pass in this object parameter as null. Now, if the form is valid, then the object is going to get taken out of the form data, and again we render the same new registration.html.twig, but in this case the object has the object value. What is happening typically on actions like this, and it's pretty common, is that at one point after you get the object out of the form, you want to persist it and store it in your persistence layer. Other things that might happen is that you need to notify someone, administrators, users who are just registered, whatever it is that this action is registering, that hey, a new registration object is being put into the system, and for this, in this case at least, we use a mailer service. This can be an internal application, something that is running locally with your PHP process. It can be also something external like Google's API, or even things like Mailgun, Mailjet, MailChimp, all of these mailing services. We also have this one here called forward, meaning that we forward some information somewhere else. We just don't only notify. And in this case, there is a service called backend. This, you may interpret it as a queue. It can be an internal API of your microservice architecture. It can also be an external API that is waiting for this information. It's not that uncommon that when something happens in your system, you have to go and notify another system. Okay, now that we know what is happening here, let's take a moment and talk specifically about the storing, the notification, and the forwarding of this object. The storing of this object usually will not take so much time, depending on the database that you are using and depending on the application's, let's call it, entity structure or infrastructure, all your schema mappings, your relationship mappings, and all of your doctrine events, if you are listening to them and doing even more work while they're being thrown. I'm going to just add a clock here to show that there is some time that it's needed here. Depending on how efficient your schema overall is, this time might be some milliseconds up to maybe half a second. Anyway, let's say that for the sake of this example, it's 200 milliseconds. Not too good, not too bad, something you can live with for now. Then we have the mailer. The mailer itself will take some time, depending on what service you're using. it might take under a second, it might take 1 second, it might be half a second, it might be 0.1 seconds. Still doesn't really matter because this will take some time. And the third one, which is the most unreliable one, is this forwarding over the backend service. The backend service may be an API that is extremely good, it's extremely efficient, it's extremely fast, or it can be an API like usually happens, where you might even have timings up to 14 seconds. What do you do then? There is nothing you can do about this API because it's just an API that somebody developed, it's running somewhere, everybody's happy because it works, and you have to notify it, and your application and page loads now take 15 seconds, 1 second to do everything since from the kernel boot, form factory, validation, persistence, mailer, and everything. You have to wait this absurd amount of time just for this backend new registration. Something that you can do to help you and make user experience much better is by using the kernel.terminate event. Moving forward, now we are going to look at some code samples, and let's dive into an already running application and how this application can be improved further. Okay, coming back to the code here, I have my local IDE and I have this project. This project will be available in GitHub. You can download it. You can look what it is doing, how the commits are changing the code slowly. Everything that will be covered throughout this presentation is available. I will link it in the end of the video too. Coming back at this running application, I would like to show you a little bit what entities are here and what it is that it's happening and how it looks like. There are 5 entities, but right now we are going to focus mainly on these 3: the author, book, publisher. There is an address entity, and this address entity is extremely simple. It has only 2 fields. It has an identifier and a street property, and then you have the accessors and the mutators here for the street field. The author itself, it's pretty straightforward, has a little bit more properties. It has a first name, middle name, and last name. It has a relationship to how many books this author is related to, and it has a one-to-one relationship with the address. The address is immediately initialized on the author's constructor. The publisher is also extremely simple. It has 3 properties. It has an identifier, the name, which is a simple string, and the last update date time. These entities are part of another presentation that I have done in the past, so I'm reusing this application. This is why some of the entities have this random lifecycle callbacks and the other ones do not. For each entity, there is a form type that we are going to interact with. There is also an address type, which is embedded in the author type. We can have a quick look here. Almost all of the form types look exactly like this. There is also in the templates something extremely simple. There is just a base template with a teeny tiny bit of CSS and just an entry page on what it is that you want to do. And if you would go through these templates also, there is only the form, which is not being rendered as form as you have seen it usually, but I had to place a little bit the labels and the widgets and the errors. The list views also just have the list entries for different entities. The price history, if you are looking at it right now, we are going to talk about it a little bit later. So how does this application look like? This is how the entry page looks like. I am in the index page and it's asking me what it is that I want to do. If I would like to go to publishers, I can do so. I will see a list of publishers and I could edit this one because I don't like its name anymore. It's Barnes and Noble's ! I click submit and something happened. Now I would like to take a moment here and just look a little bit in the network tab and how long does this method take, because that was a little bit too long. For example, if I go to the home page, The homepage is extremely fast. So localhost here, which is our index page, takes about 461 milliseconds. That's quite fast. If I go to publishers one more time, the publishers itself is 316 milliseconds. And if I go and edit this Barnes and Nobles, and I remove the exclamation mark because I don't like it anymore, and I click submit. So there is a 302 here, which is taking 1.43 seconds. And the 302, it's our post method. And let's have a quick look what is happening in our post method. This is being handled by our controller, and the controller is the create controller. The create controller will contain all actions, how to create a publisher, how to create a book, and how to create, an author. Now let's look what is happening on the publisher creation. We are calling the form factory and we are telling it to create me a publisher type with a new publisher object. Then the form is going to handle the request that is coming from the action, and we are checking whether the form is submitted and the form is valid. Of course, when we are posting it, our form is submitted, and in this case the form is also valid since I'm not applying any assertion. Then what I do is that I tell the entity manager to persist me the form's normalized data, which in my case will be the publisher object with updated data from the request that was submitted for our form. And I tell the manager to flash. Something else that is happening is that I have an API. This is the one that I was just mentioning a few seconds ago. This API needs to know that I just got a new publisher. So I have to post into this API under the publishers here resource, and I need to send this payload. Practically, it's an array with a key value where the key is going to say publisher and the value is going to be the publisher object. After this is done, then I can redirect to the list publisher. I would like to stop a little bit on this API because this is just a mocked client. This is not an actual API. It was created just for the sake of this presentation. What is happening in the post method here is that the moment that the post method is called, we log that we called it, and at least we log which method was called with which URI it was directed to. And then I have a sleep function here, which will randomly sleep 1 or 2 seconds. This is in a way to mimic a not so great API. This is also, I would say, realistic because APIs that are less than a second, while should be the norm, it is not really the norm, unfortunately. In the end, we are going to return a valid response interface, but we are going to use the mock response from Symfony by just adding a JSON encoded payload here, and by adding a random, well, not so random, but by adding something that tells us, hey, there's a location here and maybe some other header. I am not relying that much into this. The only thing that I rely on this is the fact that it will take some time. This way I have the same thing on my create controller. When I create a new publisher, I'm going to post into the API. I'm also going to post into the API when I create a book. And I'm also going to post into the API when I create an author. The same thing is going to happen in the edit controller. The edit controller is slightly more advanced. The edit controller takes an identifier in the route, and it will convert it into a publisher object. Now the form is being recreated like before, but it's just being bound to my actual publisher object. We create a form object from the form factory just like before. We tell it to create me a publisher type and bind it with the publisher object that I just got from the param converter. The form is going to handle the request. The request is maintaining the updated data that I need to get into the form. The form is going to be submitted when it's a post, and the form is going to be valid. Now, when I say form get normalized data here, I'm going to get the updated publisher object with the data that's coming from the request. This line here is completely optional. I just kept it here because I'm used to write it. The manager is flashed, and then the API is going to do a put operation over the publishers. And again, the same payload is going to be forwarded. Once this is done, the redirect response is going to be called. The same thing is happening for the publishers, as I showed here, and The same is being applied for the authors and for the books. Something else that I wanted to show you has to do with the profiler here. So we have this Jane Foster here. She lives in Carrot Street. We did a mistake here because Mrs. Foster's name is Foster and not Poster, so I'm going to edit. We're going to update her last name and we're going to submit. If I go over here and I actually look into the profiler for the post action here, and we go to performance, we're going to notice something. So almost everything is really fast except for the controller. The controller itself is going to take almost the entire time to do anything about this. The other stuff that are a little bit more resource heavy is the param converter. This one, it's still 73 milliseconds, but this one, it's the big one. It's the one that's going to pull the heavy weight. If I go over at the logs, you will see here in info and errors that we are putting our log and we're saying that the client put method is going over at the authors. I'm mentioning this because this will be slightly important once we move forward. And through the magic of video editing, I already applied the changes and the application flow has changed. I will show you real quick what is happening, and if anyone has questions, please you could either ask me if you are live at the presentation, or you can open an issue over at the GitHub repository. I'm more than happy to answer all of your questions. So I have here an API object interface. The API object interface is going to be my data transfer object that I would like to use so that I could make it in a way that I interact with this API through something that's pretty abstracted. I want to know what's the payload. I want to know what's the URI, and I would like to know what's the type of the request that I want to do. In here now I have an author API object. This one, it's pretty straightforward. It accepts a type, a type, a URI, and an author. It will transform the payload how it is required for the API, and the other ones are plain simple how they come from the constructor. The same logic applies to the book API object, and the same for the publisher API object. Something that I did change is in the client. I created a new method and I call it request, and the request is going to accept the type, URI, and payload. The post, get, put, and delete methods from before are going to stay there. They can be used by other code that relies on them, and I would slowly either deprecate them and remove them over time, or I could make this even a little bit more fancy. The reason why I added this request method is so that I can have one centralized bus. What is the principle of what I would like to do here is that in my edit controller, my create controller, or my remove controller, I have to start and collect data. I have to start and collect points of information that I tell my API service later on that, hey, I have a bunch of things that I want you to forward, or I have a bunch of things that I want you to request to this external API. So that I could, in order to avoid having a bus that collects post objects and a bus that collects put objects and a bus that collects delete objects, I just added this, where are we? Here, this request, so that the object itself can tell me what sort of type it is, and then I make a simple request. The bus itself, it's nothing super complicated. It's pretty simple. It has an internal array where it collects the API object interface objects. They are just added one by one, and once you would like to get them all, you just say give me all, and everything is given back, and that's it. Something that happened in the controllers now is that, for example, in the create controller, instead of calling the API directly, we do not do this anymore. Everything else stayed the same. We just tell the bus that, hey, I have a new publisher API object. It's of type post. it has to go to the publisher's resource, and here is the publisher object. The bus will just collect this, and the redirect response is going to be returned. How does this help me? Well, for starters, the API is not being called here anymore. So I immediately know that the create publisher action, it's going to create a form, handle the form. Sorry, the form will handle the request. The manager is going to be flushed. Something is going to be pushed here, and then a redirect is going to happen. There is no longer this call that's going to happen. What is new is that there is this subscriber. This subscriber is, I call it the terminate subscriber. You can call it however you want. I think this one makes it pretty clear, at least what it's listening to. What this one is doing is that it's implementing the API aware interface. The API aware interface, it's an interface that will auto-configure this service in order to set the API service. It's also going to need the bus service that we are using throughout our controllers, and then it's going to let you know that it subscribes to the kernel events, and more specifically the terminate event. On terminate is going to call the onTerminate function, and on terminate function we're just going to loop through all what the bus collected, and then we're just going to say this API request item type, item URI, and item payload, and that's it. Now let's see how our application flow changed. So I am back to our authors, and this is the old profiler that we just watched some seconds ago. And I would like to add a new author. And my new author, it's called Erika. Her last name is Mustermann, and she lives in Mustaveg 1. Because why not? Before I submit, I want to look a little bit on my network, just so that I can see at the post event. So this is the 302, and this is the post event, and this is the redirect this is the get response to list all the authors. Some of you might notice that this took 2.33 seconds. I will come back at this in a moment. What's important here is that our post event took 587 milliseconds. This is a big drop, and we know that the post event is calling the API. It is within the same process. It's just that the moment when that one is being done, it's at a different time. The 302 here, it's immediately being streamed back at me, and this is taking less than 1 second. Before it was taking always more than 1 second. Now, the way that I'm running this application is by a plain PHP process. So within the same PHP process, the terminate event has to run, and this is why now my get authors list now takes longer. With a proper setup, this wouldn't be the case, but I digress. So I would like to have a look now at the post token that we got from the profiler here. Performance-wise, the total here is the same, as I said, because I have just one PHP process handling everything. But something changed, and changed dramatically. You can see that from the kernel request until the controller and the kernel response here is the moment when the response is being streamed back to the client. Now the kernel terminate will take most of the heavy lifting. In my case here, it lasted almost 2 full seconds. And this is what is happening after the response is returned. To show this a little bit, in the public folder, we have our index.php, and this is what's happening. So the response is send, and then the terminate event is going to be called. This is why also the order of the timeline, execution timeline here changes. And when it comes to our logs, nothing changed because everything is being called as it was called before. If you look here, it will keep telling you that the client was called under the request method. Now it was a post type and it was under this URI. And that is all for the kernel.terminate event. If your application is running in console mode, most commonly via consumers or something like this, then you can use the console.terminate event. It acts exactly the same and is for that exact purpose. Moving forward, I would like to stop a little bit on the data value holders. What are they? Well, the thing with data value holders is that they are nothing. This is just a term that I have coined and created so that I can get people to listen about what is this weird thing that he's talking about. And I'm sorry, I know it's a shocker. I was also shocked when I learned that the book-driven development is not a valid paradigm. But let me explain. Most of us have heard about the data transfer object. If you have never heard about a data transfer object, they're supposed to be very simple dummy objects that are used for communication between processes. They do not have any behavior, they do not execute any code, they do not have any identifier to them, and they do not have value. Now, I've put value in italic here because I don't want to go deep into the philosophical discussion on what constitutes value. Generally, data transfer objects are discardable and nothing happens if you discard them. Well, probably your processes will break because they need them to be chained, but that's completely something else. Alongside data transfer objects, for the longest time, they were confused with value objects. Value objects are very similar to data transfer objects, except the fact that they are a simple entity whose equality is not based on identity, rather on value. Now, what I do is that I combine a little bit the idea of a data transfer object, a very simple dummy object that you can store data inside and have it so that you can move it along your application processes, and the idea of the value object, and I call these ones a data value holder. You can call it a data value object, you can call it a value object, you can call it a persisted data transfer object. It doesn't really matter. What matters is that what these objects do is they do nothing. They do not have any behavior. They are still a simple entity whose equality is based on value, meaning that you could load 3 different objects from the database, but they are the same object because they have the same value. And they are used for fast communication between processes. I usually target a very specific scenario when I can use this, and I make it so that I can make my application more efficient and do less database querying. To achieve this, I use Doctrine Embeddables. I have a quote here from the Doctrine docs that says, "Embeddables are classes which are not entities themselves, but are embedded in entities and can also be queried in Doctrine query language. You'll mostly want to use them to reduce duplication or separating concerns. Value objects such as a data range or address are the primary use case for this feature." I would like to directly move back to our application and let's look at some actual code sample and how we can modify this code in order to make something better. So going back to the application, I would like to show a little bit the price history entity that I have here, because this is a very interesting entity. It's an entity that is used whenever a person edits a book and updates the price of the book. When the price of the book is updated, we make a price history entry. This entity has an identifier field created at date field. It has a price column and it has a relationship to the book it belongs to. And this is something that's very common. This is something that I have seen in a lot of projects, and this is also something that I have probably done many, many times. When I needed something like this, a many-to-one relationship, where the one entry I usually need it as a reference. And this is the go-to and how most of everyone would do it. Then the getters and setters are pretty standard. The only thing that's a little bit wonky about this one is that there is a Doctrine on Flash listener the Doctrine on Flash listener here, it's not because this is the best way how to do it. This is because this application is used for showcasing a few of Doctrine events, and this one actually was the one that showed you how painful it is to do things on Flash and why wouldn't be a good idea to do it in the first place. If you have to do it, this is how you do it. So let's see a little bit like what is happening on this on Flash. We are looking whether or not we have a book that is being flashed, and we want to check whether or not the old price is not null. The old price not being null means that somebody set a new price. So we create a new price history, we set the old price, and we set the book so that we can keep track of which book this price history is related to. Then we persist the entry, and because of on-flash rules, we have to compute the change set for the price history metadata class for this entry so that it is actually scheduled for insertion into our database, persistent storage, however you want to call it. And that's it. Anytime a book is updated, and when specifically the price field is updated, a new price history entry in the database is being created. So over at the applications, we have our publishers, we have our authors, and we don't have any book right now. Let's create a book. For the book, we are going to use a random ISBN. And for the title, I was playing around here and Harry Potter kept popping in my mind. So there's a lot of Harry Potter references that are spread out through the application. And when I was choosing for a title the first time, I noticed that if you change the H and the P from Harry Potter, it becomes Perry Hotter. So that's a thing now. We have a book named Perry Hotter. It's published by this very shady publisher from a very nice German couple called Max und Erika Mustermann. And we need to set a price. What would be 20 euros. Submit. Great. So now we have this very nice book. It's available in our system. Now you can see that here there is a show history, and let's see what's the history of this book. And the history is empty because we just created the book. There is no price change. I would like to stop a little bit here and notice what is happening with the database queries. There are two different statements and two different database queries. One database query is selecting from book, and since the book is set to eagerly fetch the publisher, it's immediately interjoining with the publisher here. And the other one is we are trying to select from price history, and we are trying to find out whether or not we have a price history for this book. This is important because what we want to achieve is to halve completely these queries. We want to make this process 50% more efficient than it currently is. Now, let's go back to the application and see how the price changes are fetched in the first place. So back to the application where we left, we can go over our controllers. We can open the list controller. And over the list controller, I would like to stop a little bit on the list price history. The list price history action is injecting the repository for price history in order for me to load the data. It's param converting something into a book, and then the repository has a method that says find by book, and here's the book. If I go and look a little bit the route definition, you will notice that there is an identifier parameter here, and this is what the param converter is using to fetch the book. The repository itself has a pretty straightforward query builder. It's saying, yes, create me a query builder for price history, where the price history.book equals the value that's being passed here. This is the parameter, order by ID descending, get query, get result, nothing fancy. And we should have a quick look also on the list price history, because this is all tied together. It's a very simple table. We have 3 columns. We say book, price, changed. Notice that this means that we will access the relationship that we have as a many-to-one to the book, and then we will need to access the title. The first thing that I was asked to do was, well, obviously you get the doctrine query for selecting the book, because in your list controller, you are telling the param converter to take an ID and transform it into a book. So let's do that first. Let's no longer tell the param converter, do not transform me this book, just get the book ID, because when I go here on my find by book method, I can make this so that I can use the book identifier in order to select the book. I removed the param converter from here. I reversed this. Instead of being a book object, I said that this is actually the ID parameter that is coming from my route here. And then I say to the repository that, hey, find by book with this identifier. The method itself will not need any update. What happens to the application itself? Well, if I refresh my page here, it is one query, and that's correct. We lost a query. That's really good job. But is it? If this is the old one, I'm going to remove this. If we open again the new one, we will notice that there is no param converter converting the book, but still we are looking for what it is that we wanted to look for. The thing is that we have 0 results. So we are not 100% sure whether or not we did remove that extra query that we wanted to optimize. So I'm going to go back to books, and I'm going to make an edit on this book. There is a discount, and this book now is how much? I don't know. It's 15 euros, 25. Great. If I go to the history, now I have a history, but my queries jumped back to 2. And if I go here, you will see that it's just the order that's reversed, because first you are looking for the price history. There is a match, the match is returned, and then this match is going to be looped through our for loop. And the moment that we will need the title of the book that's assigned to the price history entry, Doctrine is going to execute a select. It's going to tell me, hey, I need the data of this book because I need the title of this book. But this book, as I said, has a publisher relationship that's fetched to eager. So we will need to also join further tables and get further data. So we did not really get rid of this query. We just moved the point in time when the query is asked. How can we do that? This is where embeddables and those so-called data value holders come in place. Because going back to the application, I want to see a little bit this price history. The price history has a relationship to the book, just to refer to the book. There is no actual business value or business logic that is required for me to have a relationship to the book. Everything that I would like to know is what is the book ISBN and what is the book's title, because I need to print the title. I will never make an operation that will make it so that I need the book relationship. In the rare occasion when I need the book relationship, if I had the book ISBN here, I might as well just search for that ISBN and load the book object. In this case, I'm going to simply drop completely the relationship and apply an embeddable here so that I can have all the data that I need nicely packed. To save some time, I went ahead and I cut the part when I'm writing all of this because we will go through it anyway. The way that you can create an embeddable, it's by using the embeddable keyword or the embeddable annotation, under ORM. And you can only target classes with this. You cannot target a property. You cannot declare a property as an embeddable, but you can target an entire class that this is an embeddable class. Embeddables only support simple column types properties. They cannot support relationships or anything more advanced than the column. In my case, what I want to achieve here is I want to create a book info value holder / data transfer object or data value holder. And I need the book ISBN, it's a string, and I need the book title, it's a column. To make things easier for me, I can immediately initialize this book info out of a book object. So I define the constructor by saying that you can pass a book, and from the book I can create everything that I need. You can have access to the ISBN, but you cannot change it, obviously. You can have access to the title, but you cannot change it. And this is something that I usually add on not most, but any of my value holders. How has this changed now the price history class? In the price history class, I have dropped the entire relationship here of many to one. And now this is with the new property annotation called embedded. I tell the price history entity that you have a property. You have a property, it's named book, and it's an embedded property. This property is of the class app entity book info. Here's the class that is your embeddable. You need to define your embeddable first, then you can use it as an embedded property. I kept the setter and getter so that I can keep the code as backward compatible as possible. I say set book again with the book object. This will mean that any possible listeners that I might have will keep using the set book completely how it used to be in the past. And I initialize the book info directly from the book object. I set it to the current book property under price history. The only thing that I had to change was that when you get a book now, you will not get a book object anymore. You will get a book info embeddable object. What else changes is the price history repository. Because of the way that you interact with embeddables, now I cannot just say price history.book is a value. I have to say price history.book.property. In my case, it's ISBN, needs to match this value. And in the list price, nothing changes. This book property has the title property also, or the title getter, so nothing will change here. Let's go and see how the application changes. Okay, what do you want to do? Yes, I would like to go to books. And I would like to edit my book. And our discount is off and we have to go back to 20. But since people will not notice, I'm going to increase it by €0.50. Great. Now I would like to see the history of the book. So, surprise, surprise, there is a database query and it's just one. And the only database query that is happening now is give me all, where is this? Price history entries whose ISBN is this one. And that's it. Because all I need to render this page is already contained within the embeddable. The embeddable is part of the price history entity, and I just need to fetch the price history entity. I don't need to fetch the book. I don't need to fetch the publisher of the book. I don't need to fetch any possible further relationships that your projects or my projects or our projects might have extra. And it's always like that. There is always that extra property that you don't need, but somehow is always being fetched. And yeah, that's it. We practically improved this entire page by doing 50% less database queries. I would say just try it out. This project itself has more properties that you can use as embeddables. I went a little bit rogue and I did not transform the address on purpose as an embeddable, just so that the people who were curious and want to try them out, they don't have to go and mess up their entire projects locally. You can check out this repository and you can try it yourself how you can make this address entity into an embeddable and just see how that plays out. This was all on embeddables. I would like to mention a few last words about this. Usually, if I would like to transform a relationship into an embeddable, there are two cases. One are the many-to-ones unidirectional, and the other one is the one-to-ones unidirectional. These are the ones that I usually find the easiest to start and transform. The other thing that is not mentioned and is edited out are the database migrations or the data migrations. In this video, this is completely removed, as this is something that you should do separately. As I mentioned way earlier in the video, this is where you can find the repository for this project. You can start from the first commit, and then you can go commit by commit, and each commit is going to cover almost each chapter, if we want to call it like this, on the topics that were covered and the parts that were covered. And in the end, I truly hope that everybody enjoyed this, and thank you very much for watching. Goodbye.